Yeah, exactly.
Okay. Yeah, so I was discussing that we have one is pointers and partials are our circular arrays,
Yeah.
right? In partials, I will save all the values of my partial aggregation. Okay.
Mm-hmm.
And in pointers, I will have some location entry.
What do you
Okay.
mean by location entry?
Means they will be pointing to some or the other positions.
Okay.
Okay. Say for example, pointer of 0 is, let's say, 3. It means I have
Yeah.
some point it is pointing to 3.
Okay.
Means the point, so it's basically I'm linking, means I have some way of linking 0 to 3. You can say it like that.
Yeah.
Okay, so these are my pointers.
Okay.
And then we have
So
a
basically we have two. So basically we have two circular arrays.
one is pointers,
One
one
is
is partials.
one as pointers, one as partials. Partial we store the partial result,
Exactly.
and in the pointer is pointing on
Some
to
location
some location.
within the window.
Okay.
Okay, clear?
Okay. Clear. Yeah.
Okay. Then we have one more stack called positions. This is of stack type.
Stack type. Yeah. Okay.
You know what is stack?
Yeah, I know that. Yeah.
So stack follows LIFO.
Yeah. Leaf.
Last in,
Leaf.
first out.
Yeah.
Okay.
Yeah.
Now positions, I will be saving the positions of this windows. Okay. So what we'll be doing, like we'll be adding some values to positions by positions dot push. So basically I'll use this for iterations.
Mm-hmm.
Okay. And positions dot pop will remove the last value and give it to you.
Yeah.
So if I give you an example, suppose positions is a list which have first value 0, then 1, then 2, then 3, and then 4.
Yeah.
Sorry. I'll explain you this again. First of all, position is vacant. It is empty.
Empty.
Okay. Now I will write positions dot push 0. Now position will have one
Yeah.
thing 0.
Yeah. In the
Now
stack.
yeah,
Yeah.
in the stack, yes. Then position dot put 1 will have 1 also. Position dot push
Mm.
2 will have 2 also. Then 3 and then
Mm.
4. So eventually I have a list like this: 0, 1, 2, 3, 4.
Yeah.
Where 0 was the first in and 4th was the last in.
Mm.
Okay. Now if I use positions dot pop,
I will take the last one.
I'll get 4.
Yeah.
Okay. And this will be removed from positions. Now position will
Mm.
have only 4 values, not this one.
Yeah.
Right. If I run this command again, position dot pop again, I will get a 3.
3. Yeah.
And next time I'll get a 2. Right.
Yeah.
And then 1 and then a 0. Then it will become empty
Yeah.
again. Is this clear?
Yeah. Yeah.
Okay. So these are the three variables that we'll be mostly working on.
Yeah.
And that covers
Position and pointer and partials.
partials. Yes, exactly. So this is covered in
Mm.
this paragraph of data structures.
Mm.
Okay. Now the preparation phase. Right.
Mm.
So now, say now what is our objective? I have to do some kind of querying, right? Aggregate
Mm.
continuous queries I have to do. No. So for any query to perform, I need to first of all do some partial aggregations, right?
Mm. Yeah.
And I need to define some kind of a range and a slide,
Mm.
right? And I need to have some kind of plan Which plan? Shared process plan.
Sharing plan.
Exactly, sharing plan. Okay. Now partial aggregation, we have three techniques that we studied: panes, cutty, and paired. Okay, so we are going to use, let's say here I am going to use paired. So now here I'm not going to go in details of what is paired. I will just say I'm going to just call this function paired, and it will give me partial aggregation values. Right. Similarly, I will call a sharing plan here, which will give me the length of the queries. Okay. And like how frequently I have to run this. I will read it out. See this. Now let's discuss. Okay, I'll read from the slides. Okay. Yeah, so in preparation where first of all we have to take some input. So input will be a set of queries queue that you want to execute. Right? And one of the partial aggregation techniques, say pairs. This we have to pass in the preparation phase. Okay. Then what we have to do, we have to start by building a shared execution plan by executing this function, build share plan function. Okay. What goes inside it, we are not bothered about that. What comes outside, we'll tell that. Okay. The shared plan includes a full list of partials, augmented with their lengths, and list of queries that need to be evaluated at each partial. So we have the shared plan now. Means which queries we have to evaluate at which partial and what is the length of that. Okay. The build shared plan function identifies the query with the longest range in terms of the number of partials. And save this range as the member W size of the produced share plan. So if you remember this, it comes from here. This this one.
The problem was this shared execution plan was not really clear. That's why I'm somehow confusing with that.
Okay. I will. So I will explain you later after this. FlatFIT, no issues.
Yeah.
Okay. So now see this. Oh, just a second. Sorry. Yes. Sorry.
Yeah.
Okay. So if you remember, I had this figure. Okay. Here we have two queries. One with a slide of 2 and a range of 6. Another one with a slide of 4 and a range of 8.
Yeah.
So we did the share processing, and finally we said that okay, if I have a slide of 2, right, I can answer to both these queries with the least repetition. Right? Why? Because if I use s is equal to 2, I can answer both this also, right? This one as well as this one.
So what about this R18, R26?
Okay, R1, what is that? Okay,
Yeah.
so basically now this will be my partial aggregations, s is equal to 2, right? So I'll be partially aggregating on 2 on this tuple. Okay. And then if for R1 is equal to 8, I will finally do a final aggregation on 4 of such windows. 1, 2, 3, 4. Not windows, 4 of this partial aggregators. Right? But for R1 is equal to 6, I will do for 3. Up to here. Is it clear or not?
Yeah. So what I understand me. Now we are talking about this multiple query environment.
Exactly. Then only shared processing will come. Otherwise, there is no use.
Yeah. So basically, in this case, the shared processing. What does it mean exactly? We have, let's say, for example, in this graph, this figure, we have 2 queries. One with slide 2 and the range 6, and the other one with the slide 4 and the range 8.
Yes.
So the idea, what we want, that we want to make a sharing process, executing plan, so that both the queries can be answered with the, we don't need to reevaluate what we already compute.
Exactly.
So how to do that?
Okay.
First we calculate this LCM, which is the least multiple, common multiple. In this case, for example, we find that we have like 4 in this case, query 1 and query 2 is 4. So 4 means that is, what is the idea why we are looking for LCM here?
Okay, fine. So see this. Now suppose I have a sliding window of 2 here, slide of 2 here and slide of 4 here, right?
Yes.
Okay. So the least common multiple can cater to both of them.
Yes.
What it means is, so 2 and 4 won't be a good example. Let's say 2 and 5.
Yeah.
So for the first one, the slide is of 2 tuples. Okay. And the second one, the slide is of 5 tuples.
Yes.
1, 2, 3, 4, 5. Now what is the LCM of 2 and 5?
10. Is it 10?
It is 10 exactly. So now if I make it of 10 tuples.
Yeah.
With 2 of each.
Why 2 of each?
Means this is, see. So now what if I make it like this, I can answer to both the queries. I'll explain you this here. Read this.
Yeah.
See this. Read this line.
Yeah.
This. Each slide is then repeated LCM upon slide times. So what is my LCM here? 10?
Yeah.
So LCM, and for one slide is 2 and one slide is 5.
Yes.
Right? So first one will be repeated 5 times. Right? And the second one will be repeated 2 times.
Yes. Yeah.
Right? Because here you had S of 2 and here S of 5.
Yes.
Okay?
Yeah.
So now if I do partial aggregation on this size, I can use for both of them.
Yes.
Is it clear?
Yeah, it's clear now. Now it's clear. Okay.
Okay.
Yeah.
So now let's come back. Here only I'm coming back. Okay. So now here, see this. So now here, so what we have done here is.
Yeah. Okay. So I'm coming to this. If you saw, they talk about the edges and the fragment. You see?
See this. Each slide is then repeated LCM by slide time to fit the length of new composite slide.
Yes.
And the length of new composite slide is 10 now.
Yes.
Is it clear?
Yes.
Okay. So now with the length of this slide, one has to be computed twice and one has to be computed 5 times.
Yes.
Okay, and all slide multiples are marked with the composite slide as edges.
This one. Okay, this one. All the slide multiple are marked with the composite edge slide as edges. What does it mean?
Okay, it means, just a second, he said, where is it? Yeah. All slide multiples are marked with a composite slide as edges. Okay. So let me make a composite slide first of some color.
We continue with the same example which you have here.
Yeah, this one only. I'm continuing this only.
Yeah,
So I'm making of 10.
10, yeah. So now we have 10. One it will be repeated 2 times, and one it will be repeated 5 times.
Right?
Yeah.
So now, if you see here, for one I will be computing which one? I will be computing this. I'll make other color here.
Yeah.
Okay, this is a composite edge. There is no composite edge.
This is the
here.
first one. With slide 2, yeah?
Yes. Okay.
And the other one will be repeated 2 times. Okay.
Right.
This is the length of the sharing
slide. Yes, composite slide.
Composite slide. Okay.
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 So now it says each slide is then repeated as to fit the length of the new composite slide, right? So this we have done. And all slide multiples are marked within the composite slide as edges. So these are my edges. These are all edges. The green ones and the red ones.
Just the edges.
Right.
Okay.
Okay. If slide consists of several fragments due to the used partial aggregation, all fragments are also marked with the composite slide as edges. This is not clear. If slide consists of several fragments due to the used partial aggregation, if 2 or more ACQs mark the same location, it means the location is a common edge. Just a second. Here he has used a range as well as slide, right?
Yes.
So we got the multiple range. No, 2 and 4. Now there is some confusion here. Just a second. Hello.
Yeah.
Okay. So let's take this example first, and then we'll come to ours.
Yeah.
Okay. Let's assume 2 ACQs that monitor max stock value. Okay. The first ACQ has a slide of 2 tuples and a range of 6 tuples. Right? So I'll just draw this in my page. 2 tuple and 6 tuples. Okay. So basically how it should look like: 1, a 2, and a 3, right? So this is my slide, and this is my
range.
Right? S is 2. Means so now the partial aggregations will be computed every 2 tuples, right?
Yeah.
And then I have to final aggregate on this 3 partial aggregators.
Yes.
Agreed on this? Clear?
Yeah, clear.
Okay, next one is what? Next one is slide of 4 tuples and range of 8 tuples.
4, 8, huh?
Yes, 4 and 8.
Yeah. Okay. All right.
Right? So now I have to do partial aggregation on this 4 tuples.
Yes.
Right? And then on
And
this 4 to get the final aggregation.
Aggregation. Okay.
Okay. So now what it says is, now here my S is 4 and range is
8.
8. Okay.
Yeah.
Now what it says is, let's read the next line. Okay. Now what it says is, now if I repeat it twice, I can cater to both of them. If I calculate, so now it says calculate partial aggregation after 4 tuples. Right?
Yes.
So I say, okay, I'm not calculating on 4, I will calculate after 2 only.
Yeah.
Because in that way I can answer both of them.
Yes, yes, because the LCM is 4.
The LCM is 4, right?
And 4 divided.
And the HCF is 2. The common factor is 2.
Yes.
Right? So now what I say, and the composite length will be how much? 4 only.
4.
Right? LCM upon LCM is the composite length, right? The LCM is 4. Okay? And this will run.
Yeah, it's 4.
Right? So now what I will do is,
you create another.
I will create this. Right? Another one.
Create the share in it.
So the range will be of the bigger one, right? Up to the 8 one.
Yeah.
Right? So this is my shared plan.
Okay.
The range is 8. Okay? And the S is 2.
S is 2.
Now to answer this query, the Q1 and this is Q2. Right? Yeah. I will take 3 partial aggregations and combine these 3. And I will answer Q1.
Yes.
Okay. For Q2, I will take these 4.
Yeah.
Right? And I can answer this. So out of 4 partial aggregation, 3 are already done. You can say it like that.
Yes.
Right? Or basically what we are doing, we are just doing partial aggregation of length 2 only.
Yes.
Right? And that is helping me save a lot of re-evaluations.
Yes.
Clear?
Clear, yeah.
So this is clear, right? So that's how we let's come back to the PDF and read it. Now read this line. The first ACQ will then run each final aggregation over the last 3 partial aggregates. This is clear, right? 6 upon 2.
Yeah.
And the second ACQ will run each final aggregation over the last 4 partial aggregates. 8 upon 2.
Yes.
Okay. Now it says partial result sharing is applicable for all matching aggregate operations such as max, count, sum, average, etc.
Yeah.
and for different but compatible aggregate operations also.
Yeah.
So means we can basically I can calculate all these functions using my queries, right?
Yes.
Okay. Now it says to determine how many partial aggregations are needed after combining n ACQs into shared execution plan. How many partial aggregations after combining n ACQs? Okay. We need to first find the length of the new combined composite slide.
Yeah, by ACM.
Which is the least common multiple of the slides of the combined ACQs. In example 1 it is 4. Okay. So this is why we want to determine how many partial aggregations are needed.
Yes.
After combining n ACQs, okay, of different slide length. So now the composite slide length is of 4. Okay. Then it says each slide is then repeated LCM upon slide times to fit the length in the new composite slide. Right? So the first slide will be repeated twice, 2 times. Right? Well, while the second one will be only repeated once only.
Can you explain this? Once it twice, one is one. Can I go to figure your figure, what you have made?
Yeah. See this. Now the composite slide length is 4.
Yeah, 4.
Okay. LCM upon slide.
The first one is 2.
First one it is 2. For the second one it is
1.
Right. Okay. Now I want to calculate how many partial aggregations I have to do.
Yeah.
How many partial aggregations I have to do. Okay. So now read this. It says to determine how many partial aggregations are needed after combining n ACQs, okay, into a shared execution plan, we need to first find the length of the new combined slide, which we have done. That is 4.
Yeah.
Right. So up to here we have done correctly.
Yeah.
Each slide is then repeated LCM upon slide times.
This one, what does it mean? This one. Each slide is there repeated.
To fit the length of the new composite slide.
Yeah.
So the first one we repeated twice in this and this.
Yeah. And the other one. Yeah, I agree.
Right?
Yeah.
Okay. And all slide multiples are marked within the composite slide as edges.
No, this one, if you
so
can.
These are your edges. This is your edges. So see this. So now what is my? Let's say this is my S is equal to 4 now, right? Composite slide.
Yeah.
1, 2, 3 and 4. Okay. So the 2 slide will have to be repeated twice. Okay. And the other one will have to be done only once. Right?
Yeah.
So now what it says is, read it now. Where were we? Yeah. And all slide multiples are marked within the composite slide as edges. So these are your edges. If slide consists of several fragments, due to the used partial aggregation, all fragments are also marked within the composite slide as edges. Now what is the meaning of fragments here?
This is the problem. suddenly we use fragment. I don't know from where it comes, this fragment.
Right. If two or more ACQs mark the same location, it means that location is a common edge. The more common edges are present in the composer's slide, the more partialization sharing can be performed. Right? So I think what it means is, see, I am sharing both these edges, right? This and this with a bigger one.
Yeah.
I have three boxes, 1, 2, and 3. Right? So this edge is shared, this edge is shared. Okay, this is not shared. Means this is shared between these two, but not with the other one. Right? So and if all of them now because these two are shared, I don't have to compute anything for the bigger one. Right?
The only one is shared is this one in the middle, is it?
No, that's not shared. See this.
Which one is shared here?
This is your fourth one, right?
Yeah.
And this is your 2 and this is your 2.
Yeah.
Right? So both are starting at the same place and both are ending at the same place.
Which one? Which one started in the same place?
This 2 and this 2. What it means is if I calculate the partial aggregation of this 2, I can find out this whole also, right?
Okay. Yeah.
Let's read it again.
Yeah.
If slide consists of several fragments with the composite slide as edges, if two or more ACQs mark the same location, it means that location is a common edge. See, now if both the ACQs are, see, if I take both these ACQs, overall they're taking the same location, right?
Yeah.
Read this line now. It means that location is a common edge.
Mm-hmm.
And the more common edge is there is more sharing.
Yeah.
Okay?
Yeah.
Fragments is not clear, right?
Maybe fragment is the window.
This one?
The hall.
Okay.
I think.
Let's try with this 2,5.
Yeah. Yeah, better.
Don't take 2,5, let's say 2,3, which are slower one.
Yeah, 2,3.
Yeah, so S is 2 for one, S is 3 for other, right?
Yeah.
Now what is R?
Sorry? You mean the ACM?
No, the range.
Put anything, put anything. Put 4. The other one is 6.
Okay.
Yeah. So then the LCM here is 6, I think.
Very good.
Yeah.
Okay.
Then the length of the sharing execution plan will be 6.
Very good.
Length.
Let me draw it.
Yeah. So then the first query will be run 3 times.
Sorry?
The first query will be repeated 3 times.
Yes.
And the other one will be repeated.
Okay.
And the other one will be repeated 2 times.
Repeated 2 times, right? But now, what will be the size of each partial aggregation?
The size is 6.
Okay. Right, for the partial aggregation, right?
Yeah, this is the length, I mean. This
Yes,
is the length.
yes, yes, you are correct. So now what I will do, I will calculate this. That's one. Okay.
Yeah.
So this will be repeated 2, this will be repeated thrice.
Yeah.
Okay. And then if I recompute it, I will get the partial aggregation of this one. And so with this one.
Yes.
And then I can repeat the same thing. Right?
Yes.
So now I am saving on my quantity.
Yeah.
Okay, clear?
Yeah, clear. So now,
just a second. Yes, yes, we are clear now. See this. So this will be repeated twice and this will be repeated thrice.
3 times, yeah.
Right, okay. And then this composite slide will be again repeated and repeated.
Say again, what I didn't get you here, what you said?
See this. What is your final objective? Here
It's
you
to
have
aggregate.
here you have the SS2 and RS4.
Yeah.
Okay. Here SS3 and RS6.
Yeah.
Okay. Now means what I have to do, I have to compute the let's say maximum for first one every 2 tuples. Okay, with the data of 4 tuples. For the second one, we have to calculate for 3 tuples for the data of 6 tuples. Right? Now, if I do like this, okay, what will I get?
So this first we compute the 3, then we switch by 2.
Sorry, come again.
For the first query, we compute the partial aggregation in each partial, the 3 one.
For the 2 tuples, right? Yes.
2 tuples.
This,
2.
This, and this,
and
right?
This. Yeah.
Yeah.
Then we switch by 2. Then we go again.
Right. But the range is 4 here.
The range is 4. So then we have to do 4 times, 2 times. We add 1 again. For the first query, since the range is 4, we compute for the first query, but now we are dealing with this sharing plan. The execution will be in the sharing plan.
Exactly. So now sharing plan says make a composite length of 6 only.
Yes.
Right?
Yes.
And that you have to repeat.
Yes. Yes.
Okay.
So we do the, yeah.
So now what we do, we repeat this partialization thrice.
Yeah.
And for this we repeat twice.
Twice, yeah. Yeah.
And what is the next
Then,
step then? How to do final aggregation then?
For the final aggregation, we need to do the first one. We compute the aggregation plan for this, for the first query, which is repeated 3 times, and we just need to share it with the other query. So we need only to add one now.
Just a second.
We will use what already computed. Because the
Now see this. So this is it, right? So now this is my new range, okay?
yeah.
6. So now I will keep on repeating like this. So this is my basic unit. Okay? That's my length of one partial, right?
Yeah.
Now I'm just thinking is, now if I have to I should repeat this window again and again, right? 6 window, 6 1. Right?
Yeah.
And if I want to compute for this, there is some missing link here. We are missing something here. Okay. Some missing hearing here. So now here it says if I have to give the answer for this one, for the range 4 and 8, what will I do? I'll simply repeat this partial aggregation 4 times and give the answer, right?
Yes.
And if I combine this 3 times, I can give the answer for the first query. Right?
Yeah.
So this is very clear. But in 2 and 5, if I use the LCM,
yeah.
So my question is, what will be this length? What will be the new S?
In this example is S2, S4.
So that's not the HCF, right? 2 and 4, it's not 4 here. It's 2 only. S is not HCF, but this is my combined. This is 10. No, the 5 is 8. Sorry.
This will be repeated 3. One, it will be repeated 3 times. One will be repeated 4 times.
Yeah, that's very easy, right? So it's clear, and we can compute whatever we want.
Yeah.
So we don't have to do much, right?
Yeah.
But in the case of this, our case, where S is 2,
no,
and R is 4, and S is 3 and R is 6.
Yeah.
Okay. If I take the HCM GCD of this,
yeah,
that will be only 1, right?
Do it again. Let's see. You have CS2, CS3, and CS5.
Greatest common divisor.
Yeah. So yeah,
of 2 and 3 is 1 only, right?
Yes.
And the composite length is 6 here.
Exactly.
Right. So now if I have a partial aggregation of only single tuple, one tuple, right?
Yeah. Yeah.
And the so it is. Yeah. Right. If I do it like this now, okay. And now if you have to answer this.
Exactly.
So what you can do?
One year it will be repeated
4 times.
4 times.
Right? And the other one will repeat it 6 times.
6 times. Using this way.
It's using the GCD, right? So I think this is this correct?
Yeah.
Let's take one more example. SS2, RS6, 4 we've already done. SX6, so RS10. Okay, so the GCD here is 2 and the LCM here is 6.
6.
Right? So now if I this is 6. Okay? And then this will be 2 only. Right?
Yeah. Yeah.
So now if I compute on, if I calculate these 3 partial aggregation, and I join them, I can answer first one.
Yes.
Right? But if I have to answer this one, I have to join 2 more aggregations, right?
Yes.
But that's okay, we can do it, right?
Yes.
I think this is correct approach, yes. So this S should be decided by the GCD and the composite should be decided by the LCM. Right, and then we can do well.
All right. So the number of tuples can be done using the great common divisor.
Exactly, and the composite slide should be done by LCM.
LCM.
But we are not using this here. This is not going to use anywhere, and they also not used it. So for 6 now, right? S should be 6, right?
Yes.
So and my LCM upon S will be 1 for this.
Like they use this LCM divided by S. So like the first one will be repeated 3 times, the other one 2 times.
1 time, na? Other one is 6 by 6, 1.
Yeah.
Each slide is then repeated this to fit the length of the new composite slide, okay?
Yeah.
Right, so second slide will be used, so this will be like this. Once only, right? Because I want different size of 6, right?
Yeah, one is will be repeated 1 time, yeah. And the other one will be repeated 3 times, yeah.
No, but then this is not correct, na? I have to collect the data of 9, 10 tuples. I am collecting only of 6 tuples.
Yeah.
Then if I repeat it again and again, no, it should not. There is some missing link here. Something we are doing is wrong. Not wrong, but it is not explained completely here. Okay, anyways, I think you got 80% of it, right?
Yeah, exactly. Yeah. So we can continue now maybe with the...
Right. Because we don't require that much in FlatFIT. I will tell you that. Okay.
Yeah. Okay.
4 p.m. I have to finish till 4 p.m. now.
Yeah.
It won't allow even one extra hour, single hour also.
Sorry?
It cannot be delayed by even 10 minutes also, right?
Yeah, this is a problem.
Okay. They'll impose some penalty. Grades. Hello.
Yeah. Hello.
Yeah.
Can you send me what you have already here, just to look at it and see if I can read it? This
sure.
The presentation.
Okay, this is not the final template. Should I send it like this as it is?
No, I just look at it and see. I read it.
Okay, I'll just mail you this. Just a second, send this guy again.
Let's write in the search bar Said or Sabir. No, Said. Said dot Sabir at hotmail.com.
Correct?
Yeah, yeah. So they said that it has to be dynamic. I don't know what they mean. Dynamic, that when you click once, it shows something. Next click,
Yes,
in
yes,
the
we'll
same
do that.
slide, it shows.
Yeah, we'll do that. We'll do animation and all will be there.
Yeah,
We'll
yeah.
put
Yeah.
everything there. Yes.
Yeah.
Okay, my colleague is working on that.
Thanks a lot. Thanks a lot.
Okay. Yeah. Okay.
Okay.
Let's come back to FlatFIT quickly now.
Yeah. We start by talking about the data structure. We said that there are three types of data structure.
Right.
We have two circular arrays. One is a pointer, one is a partial. The partial will store the partial result, and the pointer will point some location. I don't know where this location, somewhere.
Yes.
And we have some data structure, which is the stack, that will store something. I don't know. The stack will store something. Is it?
Stack will store positions basically. Right?
Position of what?
We'll see that.
Okay.
It's like basically it will position that stack will be used for iterations.
Okay, so basically stack will store position. All right. So now we were talking about this preparation phase, which is the one.
Right.
And we say that
we'll call a shared
preparation phase. We need to call the shared plan. We've already talked about it now.
Right. And in shared plan, we have to call about two inputs. One is the queries, which we have to compute. Another is the partial aggregation technique, PAT.
Let's say the partial since they are using PAN, let's call it PAN.
Okay.
Because the most they are using, I think. So we call the partial aggregation the sliding technique. This is basically the sliding technique.
Right.
And also the query. All right. So now this. Okay. So then what? Now we get an object. We get something called shared plan.
Exactly. Okay. Now we'll explain this with the help of an example. We'll put some values to each one of them. So it's easy to explain.
Okay.
Okay. Now let's see what is the example here. Okay, read this example now. So first example is a single query environment where we're going to just pass one query. Assume we have just one query Q1 which is seeking the max value over the range of 5 tuples with a slide of one tuple.
Okay.
Okay. Since the slide size is set to one tuple in this example for simplicity, which means that there is no partial aggregation, right?
Yeah, there's no only one by one. Yeah.
No aggregation, right? And the answer to max needs to be calculated after every new tuple arrival.
Yeah.
Clear?
Yeah.
Okay. A shared execution plan is not needed in this example because it's only one query.
Yeah.
Right? Which makes our window size equal to range, that is 5. Composite window, composite slide.
The composite, yeah, we talked about, yeah.
This is 5 tuples, right? Because we have to compute every 5 tuples.
Yes, yes.
Sorry, we have to compute the data. Data should be of 5 tuples, computing every single tuple.
Exactly.
Okay?
Yeah.
Good. This is clear?
Yeah, yeah.
Now what we'll do, we'll go to the pseudocode quickly. Okay, sorry. With the shift F5. Now I'm going to put some values over here. So W size is what? 5. Right?
Yeah, yeah.
Okay. Partial. So now partial is a new array of size 5.
Yeah.
Right? Pointer is again new array of size 5. Empty arrays. Right? Positions is a new empty stack.
It's empty stack.
Okay.
Yeah.
Now I am going to initialize it, put some values here, initial values here.
Yeah.
So now W size is 5. Okay. For I is equal to 0 to 5, partials of I is equal to initial value.
0.
Right? Not 0. In the case of maximum, it should be minus infinity.
Minus infinity. Yeah, yeah, that's true.
Correct? Clear?
Yeah.
In case of sum, it should be 0. Yeah, in case of count, it should be 0.
Yeah.
Okay. So which we can put. So I'm taking the example of max, so it is minus infinity.
Yeah.
Okay. Now look at this point. Pointers I always mark at the next position. So pointers of 0 will be 1. Pointers of 1 will be 2. Pointers of 3 will be 4. Pointers of 4 will be 5. Right?
Yeah.
And then after that, this one. Pointers of 4 will again 0. So here I made it circular.
Yeah.
Clear?
Yeah.
And then we define 2 more things. The current index where the new tuple will enter.
Yeah.
And the previous index where we will store the partials.
Okay.
I explain you this, okay? Now after understanding this, I will come back to this figure again. Which figure? Sorry. See this now. This is the initial position. So these are my positions. 0, 1, 2, 3, 4 are my basic positions. Okay. 1, 2, 3, 4, 0 are the pointers value. So 0 is pointing to 1, 1 is to 2, 2 is to 3, 3 is to 4, 4 is to 0.
Yeah.
Right? Partials have minus infinity values. Is this clear?
Yeah, yeah.
Okay. Now the first value 2 enters.
Yeah.
Okay. So in the naive method, 2 will enter in the 0th position, the first position only. That is my current index. Okay. Oh, sorry. See this now. Yeah. So current index is 0. Previous index is 4 now. 5 minus 1, that is 4. Okay, so phase 1 is over now. So there is no looping here. This is just initialization of current index, previous index, the filling of partials and the pointers. And the position is empty right now.
Yeah. Exactly.
Clear?
Yeah, clear.
Okay. Now comes the execution phase. Okay.
Yeah.
Now let's start from here. So in the execution phase, what we have to do? So we have to go for this. While results are expected, do this. Okay. I'll just remove this. Okay. Length is shared plan dot get next partials length. Okay. So since here we are tuple size is 1 only, slide is 1, so length is 1.
Yeah.
Right?
Yeah.
Now we pass on to the partial aggregator function, which is aggregating it. Okay. So here the length is 1,
Yeah.
so partial aggregation is doing nothing, so we'll get, so we have passed 2 here. Value 2. Where is this 2 coming from? There's a new value that is entering at t is equal to 0. This 2. This 2.
Yeah.
Okay. Since there is no partial aggregation, we are saving it as it is. Right? Clear?
Yeah.
So the value of new partial is now 2. Okay. Now see this. Partial of previous index is equal to new partial. Now previous index is what value?
4.
Very good. So partial of 4 is 2. Okay. I'll just open this also. Yeah. So 0, 1, 2, 3, 4 pointers and partials. So earlier it was, initially it was what? 1, 2, 3, 4, 0 and all minus infinity. Right?
Yeah.
Step 0. Okay. Now the value 2 comes in. Okay, step 1. The value 2 comes in. Okay. So it is going to be saved in the, I'll just 0, 1, 2, 3, 4. So now pointers are going to get update. Okay. So this has become 2 now, the partial. Right?
Yeah.
Right now pointers are this only, but they will change. So I'll write the new value, updated value over here. Okay.
Yeah.
So I'll just put a blank over here so that we remember. And these are also blanks. Or minus infinity as of now. Right? Okay. Now, so we are done till here. Okay. Pointer of previous index is current index. What is the value of current index?
It was 0.
0. Previous index is
4.
4. So, sorry.
Pointer of 4 will be 0.
Exactly. Pointer of 4 will be 0. Oh, this pen again. Yes. So see, this pointer of 4 is now 0. Right? I'll update it in my OneNote also. Pointer of, this is my pointers. Okay, let me change the color. So this is 0. Clear?
Yeah. Yeah.
Okay, so we are done till this.
Yeah.
Where are we done till here? Okay. Now we have to answer some queries, right? So we'll call shared plan dot get next set of queries, right? And we'll save it in queries to answer. So since it is a single query, I will have only Q1, right?
Q is, yeah,
so it says
one.
For each query Q in queries to answer do. So now this for loop is of no use for us because I have a single value only.
Yes.
So it will run only one time.
Yes.
Right?
Yeah.
Now look, now see this. Starting index equal to current index minus range of the query.
Yes.
Or the window size.
Yes.
Right? So what is the range of the index? Range of the query 5. What is the current index?
It was 0.
0. So what is start index now?
Yeah, it's -5.
It's -5, right?
Yeah.
But it says if start index is less than 0, then we have to do this.
Yeah.
Okay. Start index is equal to start index plus W size.
Okay.
So start index will become -5 plus 5, right?
Yes.
So start index becomes 0.
Yeah.
So my what do you call updation of value start at index 0 only.
Okay.
Okay.
Yeah.
Now comes the interesting part. Now I'm going to fill these positions. So I'm starting at index of 0. So positions dot push 0. Okay. So I will update my positions now. Okay. So now positions is a stack which has a value 0. Right, Syed?
Yeah.
Okay. So position is 0 now, right? I'll just put it here also. So this is 0. Okay. Now start index equal to pointers start index. So pointers of 0 is equal to start index. So this is a loop.
Yeah.
Why is a loop? Because pointer of 0 was 1 earlier. If you see this, pointer of 0 was 1 earlier.
Yeah.
Okay. So now start index gets upgraded to 1.
Yes.
Right. So it's a loop now. Okay. Now it says check first. If start index is not equal to current index, keep running this. Okay. So now current index of start index is 1, current index is 0. So run again. So push 1 also here. So I will get 1 also here. So 1 is also here. So now it becomes 0, 1. Right?
Yeah.
Now again pointer of 1 will become 2. Pointer of 1 is 2. So start index again gets upgraded to 2. Right? So pointers help us to scan the complete circular array. Okay. So pointers of 1 was 2. So this is also 2 now. So 2 is added. Clear? Okay. Now where I am, so again it's not matching, I come again. Now it is 2 is also added, now it becomes 3. Okay. So 3 is also added. Now it comes 3, it becomes 4. Right? Now comes the interesting part. As soon as I put 4 here, I know here the pointer to 4 is 0. Right?
Here, yes, yeah.
So again back to position 0. So the start index is 0 again.
Yeah.
Okay. And now start index matches your current index.
Yeah.
So this while loop will break.
You do pop.
Clear or not?
Yeah, clear. Yeah.
So we are done with this loop. So this is your basic iteration loop.
Yeah.
Okay.
Yeah.
Cool. Now let's save the answers. Now what is the value of position dot pop here?
It was the top of the stack. What was?
Sorry?
Can I see the stack? What is the last current? Yeah, it was.
It will be 4, right?
4, yeah.
So this is 0,
Okay.
1, 2, 3, 4. So this will come
This is what they mean by novel index here.
Yes, novel indexing, yes. A new methodology, right?
Yes.
So now we are done till this first page. We have completed this up to line 35. So now the answer is what?
The partial, we take the position,
partial
we pop
4.
the stack. Yeah.
And what is partial of 4? We saved here.
Yes. Yeah.
Tell me the value.
Partial is not partial is 4.
No, partial of 4.
It was. Yeah. Wait.
Okay, think I'll just bring some water. Okay, just think.
Yeah.
Hello.
Hello.
Yeah. Shall we resume?
I'm just thinking. Yeah, can I hear you? The partial for the positions when we do pop, it was 4. It means the answer will get the previous index, is it?
No, see positions. Okay, see the position dot pop is 4, right?
Yeah.
So I want to get the value partial of 4, right?
Yeah.
Now if you look at line number 22,
Yeah, partial of 4. Yeah.
is what 2.
Is new partial is.
New partial is what the value we pass. That is 2 here.
Yeah, 2.
So this is answer is 2 right now.
Yeah.
Okay.
Yeah.
Clear?
Yeah, clear here.
So the answer is 2.
Yeah, the new partial is 2. Yeah,
Right
the
now.
first
Okay, it's saved over here.
Yeah.
Just remember one thing in this new method now, if the value enters at 0, the partial will save that previous one.
Yeah.
Okay, now let's move ahead.
Yeah.
Now see this. Now again we are entering a loop. While
Yeah.
position dot size is more than 1, do this.
Yeah.
Okay.
Okay.
Now position dot pop. What is this value now?
We get the position, the first one, which is what was 4?
Now 4 was already gone, no?
Yeah.
4 is already gone here.
We take the next one, which was 3.
It was 3. So temporary index is 3 now.
Yeah.
So now we are updating the answer.
Yeah.
So in our case, it is maximum of the answer and the partials at 3.
Yeah.
Understand this carefully. Partial at 3 and the answer was 2.
2.
And we have to find the maximum of both.
Yeah.
Right? Now partial of 3, initially it was minus infinity.
Exactly.
We have not updated it right now. Okay?
Yeah. So 2, we will have 2 still.
Yes, we have 2 still, exactly. Very good. So now answer is 2 now.
Yeah.
Okay. Now look at this. So now partial of, we are updating the partial now. Partial at 3 is 2 now. Okay. So see this. Now this value, this minus infinity is gone and this has become 2 now. These are minus infinity still.
Exactly.
Clear?
Clear, yeah.
Okay. So yeah. And now this we are updating the pointers also. What is current index?
It was 3. It was
current index. The value enters at this. It's 0.
It was
it's 0. Right?
0. Yeah.
Right. So 0 is what? Now pointers of 3.
3.
So pointer of 3 also now pointing at 0. Earlier it was pointing at 4. Now it is updated to 0. Okay.
Okay.
Now let's do next. So now, okay. So we are done. We run the loop once. Okay. Now we'll again check the size of positions. What is now? What is the value of this now? Position dot size
is position size 3. No, 2. 2.
No, not 2. 3. 3 is 0, 1, 2 will be there, no?
Can you see the figure which you have?
So we popped 4 and we popped 3.
Yeah.
0, 1, 2 are left, right?
Exactly.
So size is 3. Okay, so size is 3, so that's why I'm again entering the loop.
Yeah.
Okay, now see this. So position dot pop, which value to return?
We take the top one, which is 2.
2. Very good. So this is 2 now. So temporary index is 2 now. Earlier it was 3.
Yeah.
Okay. Now again I am checking the answer, updating the answer.
It will be again.
Answer and partials of 2 now. Okay, and answer is 2 earlier, right? And partial of 2 was minus infinity. See this.
Yes, so we need to update it also.
So still the answer gets updated again. Still it is 2. Right?
Yeah.
Okay. Sorry. So
Yeah.
now see this. So now answer is 2 is saved in partial of 2 also.
Yeah.
Okay. So this value becomes 0 again.
Yeah.
Sorry, not 0, 2.
It will be 2. It will be updated to 2.
Clear?
Yeah. Clear, yeah.
Just clean this a bit and write it 2 over here. Yes, it is 2. Okay. And now pointers of 2 is again 0. So pointer of 2 is again 0 now. Okay. Now again check the value. What is the size of positions now?
Is 1?
No, not 1, 2, 0 and 1. We popped up 2 last time, right? So 0 and 1 should left, no?
0 and 1, yeah?
So 0 and 1 size will be 2, right?
The size is 2, yeah.
Right? So that's why we're entering which is more than 1.
Yeah. Sorry, I'm talking about the size. Yeah, I would. Oh, yeah.
Okay, so we're entering the loop again.
Yeah.
Now what is positions dot pop?
1.
1. So temporary index is 1 now.
Yeah, 1. Yeah.
Again, I will compare the value of 2 with partials of 1.
Yeah. So
partial of 1 is still minus infinity, right? So this is still, the answer is still 2 now. Okay. Now pointers of, what was this? Pointers of 1 is again 0. So pointer of 1 will be 0, right? And partials of this will be answer. This will be 2 now. Okay, this is also updated now. Clear?
Yeah, clear.
Okay, now see this. Now look at this. So now, okay, now let's come next time. What is the size of positions now?
1.
1. Should I enter this loop?
Why? No.
So no. So with this loop is over now. So we have executed this. Okay.
Yeah. Okay.
Now what is position.pop will give you?
Position pop will give us 1, 0.
Exactly 0. So temporary index is 0 now.
0 now.
So again I'm matching the first partials of 0 with the answer that is 2.
Yeah.
Okay. So this is, so now this is again minus infinity and 2. So this is maximum is still 2. So answer is still 2 now.
Yeah.
Okay. And send the answer. So this is the answer of the first 2.
Yeah. Okay.
Okay. Now this is
because
the first is over. The first updation is over with the new value. Okay. Now what I will do, I will change the value of previous index to current index, so it becomes 0 now. Okay.
Yeah.
And I increase the current index by 1. Okay. And then I am ready to take the new value. Where?
Because the first one, in the first one we are only comparing the first value with the infinity, so it will be clearly the max.
Right.
Once we see the next value, then we are comparing with 2.
No, that's okay. The major thing that you have to explain here is, so there in the first step there is no improvement as compared to the earlier methods. Why? Because I have to compare with all the values. Yes?
Yeah.
I compared my answer with all the 4 values.
Yes.
Right? In the basic method also we have to do this only. The improvement will come from the second step.
Second step. Okay.
Yes. The reason is why? Because now there is no minus infinity. All are 2 only.
Okay.
So if I compare with any one of them, it is okay for me.
Okay.
And that will be done in the next step. So now let's come back here. Okay, so now let's look at this step. We have done this successfully.
Yeah.
And the maximum value is 2 here.
Yeah.
Okay.
Yeah.
Good. Now 4 enters. 4 value. Okay. So in the basic method, it will enter in the first place only. Right. But in our case, if it enters in the first, the partial are saved in the 0, 1 before. So partial are saved is 0. Here 4. Okay. I will come back to the code and run the code again. Now you have to say I will not speak. You have to speak.
Sorry?
Now you have to explain me this.
It's me. All right. So, all right. So no.
Tell me the value of length now for the next partial.
The length of the next partial length is still is 5. What will I say? Is 4 or 5?
No, it's not neither 4 nor 5. It is 1 only, na? You're computing it for a single tuple.
Yeah. Sorry. I'm talking about. Yeah. So now the next number come. Okay.
The next number is 4. Next number is 4.
Okay. Yeah.
Okay. Now tell me.
4. Is it 4? Okay. So the next shared execution next partial length is 4. Okay. So partial aggregation length is 4, and is pan. We take okay, no problem. This is new partial.
So what is the value in new partial now?
The new partial is 4.
Very good.
Yeah.
Okay.
So then we have partial previous index. Previous index was 0. So partial is new partial. So then it will be the partial of the previous will be 4.
The partial of 0 will be 4. Let me update it now. Okay. So I will just write this down again. 0, 1, 2, 3, 4. Okay. Yeah. Now partial of 0 you're saying is 4, right? So this has become 4. Okay. This is my partials. And these are my pointers. Yes. Okay. Now.
Okay. So then the partial of previous index is 4 pointers of 0 is a current index, which is 1.
Pointer of 0 is 1. Excellent. Pointer of 0 is 1. Okay.
Yeah.
Good. Now next.
Pointer of 0 is 1.
So we are done till here, right? This line number 23 is done.
Okay. So the query to answer is what is the share plan get next set query. So as we said, get next query. So now we have a query, which is the maximum. Okay, query to answer. So we need, let's go to the loop now.
Okay, there is no loop because we have a single query only, right?
Yeah, only query, yeah.
Okay, then?
Then we start index. The start index is the current index, which is 1 minus the query range, which is query range is 1.
No, query range is not 1. We are executing it every 5 tuple, right? For the 5 tuples. Range,
yeah, 5.
Range is 5, right? Slide is 1, range is 5, right?
Yeah, the range is 5. The range is 5, and the current index is 1. So minus 4. Okay, so we have the start index is 4, and we compare it with 0. Then it's not less than 0. So is -4. Yes, it's less than 0. Then what we do, we take the start index is what is the size of this window size, which is 5. Yes, window size is 5.
What is the value of start index now?
Start index is what?
You know what is the meaning of this sign?
Yeah, I know. Is the start -4 plus 5 is 1 plus 1 is 1.
Very good. This is 1.
Yes.
So just remember, the last loop started at 0. This started at 1.
Yeah.
Okay, good. So we are done till here. Excellent. Now what?
So now we have we go to the position, the stack. What we do, we have to push this 1. We have to push 1.
So we pushed 1. So in the stack we have first one value is 1, right?
Is 1, and we need to take this pointer, which is the start index. We say it was 1. So pointer of 1.
What is pointer of 1?
Is 1?
No, earlier.
Is that? It was pointer of 1 early.
Yeah, the previous iteration.
Yeah, it was 2.
No, pointer of 1, not partial.
0, 0, 0, 0. Sorry.
It was 0, right? So start index is now 0.
Yeah. It was 0, yeah.
Okay, so this has become 0 now.
This becomes 0. So the start is 0 pointer in this, yeah. While this is different from current. The start index is 0. The current index is 1. So what we do? We're in the do while. We're in the loop. Since the start index and the current index is not the same,
we run it again, right?
Yeah.
We'll come back.
We need to do it again.
Yes. Now what is start value of start index?
The start. So now the start index push. We take the next one, which was we push the next. The start index. It was.
Okay, I have to complete the slides also quickly.
I have to go through it. Now I have it. I just need to go through it. Wait here. Start index is 0, isn't it?
Exactly. Very good.
Yeah.
So now I will push start 0 also here, right? So 0 is there.
Yeah. Exactly.
Now what is pointer of 0?
Pointer of 0 is.
Wait.
Yeah. It's
It is 1, right?
Yeah.
So now
exactly.
Start index became 1 again. Okay.
Yeah.
But so pointers of 0 is start index became 1, right? And now it is equal to the current index.
Exactly.
So this loop is over.
So when it's over, we have to take we pop up the.
So now we have only 2 values, right?
The only values.
Hello.
1 and 0.
Right. So now so now here you have to explain your professor that earlier we have to iterate over all the values. Now I'm only iterating over 2 values.
Exactly.
Right. So now I have to compare just with one other value. Do this now. Okay.
Yeah.
And that's where this FlatFIT improves the execution.
That's what I was looking for. Yeah. Exactly. Yeah.
Clear?
Yeah.
Now do this. Now execute line number 35.
Yeah. So now we have to pop the 0 and put it in.
We'll pop 0. Partial of 0 will be your answer. What is partial of 0?
Partial is the 0. It was 2, I think.
No, it's not 2. It's 4 now.
Okay.
Because the value is entering at 1. So
it's 4.
Okay.
Yeah, it was 4. We updated, yes.
So the initial answer is 4. We have not compared anything. So basically, so this is okay. One more thing. This is always going to store the new value.
Exactly.
Okay. Now let's move ahead. Okay. Now do this. Next slide. Yeah. Okay.
So we have now we need to check the size of the position.
Position. So what is the size of position now?
The position size is 2, is greater than 1. Then
Wait,
what
no,
we do, we take.
no. It's not 2. It was 2. You already used position.pop once.
Yeah, 1.
So 0 is already popped out. So only 1 is there, right? Size is 1.
Yeah.
So you're not entering. You're not entering this loop.
Exactly.
And so you're not comparing with lot of values. That's the benefit now.
Yeah.
So okay. Now come again. Comment line number 42.
Yeah. So now we need to update now. Okay, we take this temporary index. It will be okay. Will be 1. We pop up position. We pop the 1 which we have, and we update our temp index.
What is position.pop? 1. Right.
1.
Very good. Temp index is 1 now. Okay. So now look at this. Now I have to compare answer with partial of 1. What was the partial of 1 earlier?
Yeah.
It was all were 2 only. So it was 2 only, right?
That's one only.
So I have to just compare with 1. 2. That's it. And answer is 4.
Yeah.
Okay. So that's the benefit.
I think I can explain it only with single query in the exam.
But this will also take a lot of time, right?
Yeah, because if I try to with the multiple query, it will take. What do you think? Maybe they will ask me, "Can you show it?"
Okay.
Anyway, well, Himanshu,
yeah.
I will go through it again. Maybe you need also time to do the slides. And maybe if you have free time, because tomorrow at 11 o'clock I have the exam. Can you please later in the night we talk a little bit so that I can.
Okay, let me finish the slide and submit to you quickly then.
Yeah, we talk later, okay? When you are done.
So okay, is it? I hope it's clear now, right?
Yeah. I just know you have it recorded. I will go through again. If you send me this, what you have recorded.
Okay, it will take some time. I'll just